So just try to read the first question. The question is an invasive species. It's given to you. An invasive species plant appears in fruit grove at time t equals to 0 and begin to spread. The function c defined by ct equals 7.6, 10 inverse 0.2, or 10 is 10 inverse 0.2 t models the number of acres in the fruit grove affected by the species t. Species t t weeks after the species appear. Okay, so t is representing, t is a unit in week. It is a time in week for you. It can be shown that the derivative is going to be equal to 38 over 25 plus t square. It is nothing but the derivative ct given to you. The first question is find the average number of acres affected by the invasive species between time t equals to 0, time t equals 4 there. So always remember, whenever you have a continuous function like you are having ct, it is continuous function for you. Over the interval, say 0 to 4 given to you, you can consider this as AB. And if I ask you the average there, it is going to be 1 over divided by b minus a, integration from a to b, the function ct dt. You need to plug the values 1 over 4 minus 0, integration 0 to 4. And this is going to be 7.6 into 10 inverse 0.2 t dt. Any doubt?
Yes, that's yeah.
And we have Desmos with us. So the calculation is going to be like 1 by 4. And then after integration from 0 to 4, you're right.
Yeah.
It is 7.6. Then after 10 inverse, let me just check. There is a function 10 inverse. And I will be having 10 inverse. How much? 0.2 t. And this is dt. The value is going to be 2.7782. So let me just take the whole value. So Desmos was very useful. After your class, I searched for the better calculations, which I can show you. I find that
Desmos
Desmos can do everything. So it is really helpful. So I hope it is not an issue there. Up to 3 decimal places, you can just round off the numbers after this, after it. So this is the correct answer up to 3 decimal places. Any doubt?
No.
Perfectly okay. Now the second question is find the time t when the instantaneous rate of change c equals to the average rate of change c. So have a look at the question. Instantaneous rate of change is going to be the derivative, and it is going to be the average rate of change. Average stands for the value of c4 minus c0, c at 0 divided by 4 minus 0. On the right hand side, you have an average rate of change. On the left hand side, you have instantaneous rate of change. Like we had, the derivative ct is 38 over 25 t square. So I'm writing 38 once in the numerator, 25 plus t square. Can you please check? This is the same thing.
Yeah.
Okay, on the right hand side, I need c4 minus c0. C0 is, I think, going to be 0 without any issue. I'll show you how. Function was 7.6. Then after you are having 10 inverse 0.2 t. Am I right? So this was the function. Let me just choose y equals to, and I will try to get the values of this function at two values. One is 0, another value is 4. Can you please check? At 0 you are having 0, at 4 you are having the value. How much? 5.128. Yes, so I'm writing this value here. How to change the color there? Let me just change the color. So this is the value you have obtained. Let me just use this value. This is going to be 38 divided by 25 plus t square. 25.1280312 divide by 4. Okay, so from here you can get the value 25 plus t square. It is 38 into 4 divided by 5.1280. From here t square can be obtained, and from here I can get the value of t. T is representing the time, so if there is a negative value, we will be ignoring that negative value, right? So let us just use Desmos again to fill the values there. So after all these values, yes, after all these values, let me just erase this. I have the value is going to be this 38 multiplied by 4 divided by 5.1280. Am I right? This was the value minus 25. So the value is going to be 46. This is the value. I'm just pasting the value. Square root of how much it is? 4.64118. It is 2.154 if it is not incorrect. I know you will be getting two values, positive and negative, but we will be using positive values only because t is representing the time there. So this is the value you will be having. Any doubt?
Yeah, it's clear.
Perfectly okay. So let us go to the next question, that is the C part. Assume that invasive species continues to spread according to the given model, whatever the CT given to you. Write a limit expression that describes the end behavior. Here the term end behavior is going to be very important. Whenever the term end behavior or similar terms appears, that means you are going to take limit t tends to infinity. So the question is
Yeah.
going to be, what is going to be limit t tends to infinity? C prime t. Limit t tends to infinity. How much it is going to be? It was 38 divided by 25 plus t square. So it is finite upon infinity. Finite upon infinity will give you 0 always. So this is going to be the end term and behavior. Any doubt? This is the rate of change and behavior of
No.
the rate of change, and that is where we need C prime t there.
Okay.
Let us
Is
look at
that
the
the
next
answer?
one. Yes, that is the answer for you, 0,
Okay.
without any issue. Now, the next question is at time t equals 4, week after the invasive species appears in the fruit crop, measures are taken to counter the spread of the species. The function a is defined like you. It is at. It is going to be ct. If you wish, you can plug the value of ct. 4 to t is the integration 0.1 ln. You will write x dx. This is the situation given to you. And this models the number of acres affected by the species over the time interval from 4 to 6. It is given to you. So for the time interval 4 to 36, does A attain its maximum? In order to get the maximum minimum, I should be able to get the derivative. And then after using derivative, I will be finding the critical point. So for the derivative C is C prime t, and the value C prime t I know. And here I need to apply the derivative. It is going to be 0.1 ln t there. Any doubt?
Right. That makes
You
sense.
can
Yeah.
apply the theorems like fundamental theorem of
FTC.
calculus,
Yeah.
whatever given to you, and differentiation under the sign of integration, you can apply those. Okay, so I
Correct.
will put this a prime t equals 0 for critical points. That means your c prime t. What is c prime t? It was 38 divided by 25 plus t square. Okay, it's 25 plus t square minus how much? 0.1 ln t equals 0. Somehow I need to find this value, and finding the value is going to be a little bit difficult. But yes, if we can use Desmos, that will be really easy. So I will be using Desmos there. Okay, and let me just show you the curve. The curve is y equals 38 divided by 25 plus t square Okay, this is the curve minus 0.1. You are having 0.1 ln t. Okay, and just look at the graph there carefully. So what I can assume that around this value, this is the point where the graph is going to intersect the x-axis. So the value of t, where the left-hand side is going to be 0, is this value. Okay, where it is going to be 0 is going to be this value. So let me just make use of it. 11.4417. So that means to say that the value of t is going to be 11.4417. Do you agree? Using the calculator, you need to find out. So now, because I was looking for maxima, minima within the interval 4 to 36, so we need to test the value of 80 at 3 different points. What are those 3 different points? 3 different points are, you need to find the value of 80 at t equals 4, at t equals what we obtained 11.4417, and at the point t equals 36. These are the points. Check, these are the endpoints, and this is going to be the critical point for you. Clear? This is going to be candid test. Now, can you just tell me how should I get the value of 80 at these points? Any idea?
Just like use
We
it
can,
back in the equation.
we wish to use the equation once more. Let me just check. 80 contains CT minus, what was your CT? CT was this term. Let me just, this is your CT minus integration from 4 to 36 you are having, and 0.1 ln x dx. The oh yes, is there any issue? I should use t there. So now the ultimate variable is going to be t. So I will be trying to get the values at do I have the luxury to substitute the values? No. Give me a second. So in this case, I will be trying to get the value of ft. Yes. I think now it is working perfectly okay. I need the value at 4. I need the value of the function at 11 point. How much? What was the point? 11.4412. And I need the value of f at 36 there. So these are the values I obtained. Sorry. These are the values I obtained. Let me just take a screenshot. You please consider ft as 80. Okay. You consider ft at 80. So these are the 3 values. At 4, you are getting 5 point something. At 11 point something, you get 7.3169, and you get 1.7. So because they are looking for maximum, does A attain its maximum value? The answer is going to be yes, it attains the maximum value. And where it attains the maximum value? It attains the maximum value at t equals 11.4417. Any doubt there?
No.
Okay, so this was the question. Just have a look at the answer, how I proceeded for the answer. Then after we'll move to the next.
Something like to say. That's good.
Perfectly okay. Okay, so it is done. Now let us go to the next question. Next question is based on the this polar equations. So yesterday only, I never used Desmos for these purpose. But yes, I was able to plot polar curves on
That's very
Desmos,
good.
like
Yeah.
r equals to, it is sine square and then after theta. So 0 to pi if you wish, only pi. And I'm going to, yes, look at the graph you are having. And one more feature I tried, like this curve. If you just look at this curve, it is like we are working with the polar equations. I should enlarge it. This is the one curve. Uh, Let me just, yes, reduce the size. Another curve is r equals like 1 by 2 you are having. And the range is going to be from 0 to pi only. Okay. So this is the similar graph given to you. Let me just show you the graph given to you in the question, and you just try to find out if we have got the same answer, same graph basically. Look at the graph given to you. It is a similar
No.
graph you are getting on Desmos. So almost everything is identical. And yes, give me a second. Can I still? Yes, I will be using this. So find the rate of change of r with respect to theta at the point on the curve C. Now, how C is defined? C is defined with the polar equation r theta equals to sine square theta, right? So if I ask you, you need to find the rate of change, that means dr over d theta. With respect to theta, you need to find out. It is 2 into 2 sine theta cos theta, right? This whole term is going to be 2 sine 2 theta. You need to find the rate of change at a specific value of theta, that is 1.3. You need to plug the value. This is going to be sine. How much it should be? 1.3 into 2, it is going to be 2.6. All the values are given in terms of radian. Let us just try to get the value of this expression. And have I marked radian somewhere? Yes, radian is there. By default, it is radian. So the value was 2 multiplied by sine, it is 2.6, if not an issue. The answer is coming out like 1.031. Any doubt there?
No.
You can verify the value using your calculator so that there is no confusion. So this is the first question where you need to find out the, after this, look at the second question. Find the area of the region that lies inside curve C, but outside the graph of the polar equation. Inside the curve C and outside the polar equation. Now the polar equation r equals to 1 by 2. So from origin, you just try to join these two lines. Now the question is, what area you are going to find out that lies inside the curve C. So check inside the curve, this is the portion inside the curve. And outside the circle stands for r equals 1 by 2 is going to be semicircle for you. You need to somehow get the area, this area.
Hmm.
Okay. So you need to find out this area without any issue. Now the question is how we are going to do this. In order to find the area in case of polar coordinates, let me just erase this for the moment. I need to find out what are these values. Because I'm using Desmos, so if you see, they are intersecting at this point. Can you check the point? This is the point, and the angle is going to be how much? Pi by 6. And this is going to be the angle how much? 5 pi by 6. So you can find out that the point of intersection is going to be at theta equals pi by 6 and theta equals 5 pi by 6. Let me just try one thing I never tried. Okay. That's the thing I wish to try. Theta equals pi by 6. Okay. Right now, I'm not able to plot the line like theta equals pi by 6. I was trying to just plot a line so that I can show you. So let me just tell you here. This is the line pi by 6 you will be getting. This is the line 5 pi by 6. Any doubt?
No.
Okay, perfectly okay. Up to this point, not an issue. So how can I get the area? The area is going to be, first of all, this area, right? This area. It lies between theta equals 0 to theta equals pi by 6 and bounded by the curve C. And you need to remove this middle one area and then after the rest of the area. Do you think symmetry is there? Like symmetry about the y-axis? Do you think symmetry is symmetry about the
Yeah.
y-axis is there? So if not an issue, I can use the symmetry about the y-axis. I will try to find the area of this part and multiply by 2. So the required area for me, the required area is going to be twice of area from theta equals 0 to pi by 2. So whatever the area I will be getting from theta equals 0 to pi by 2, I will be going to do that twice of it. Any doubt? Any doubt here up to this point?
No.
Perfectly okay. Now I'm going to tell you what is going to be the area. Check. If there is a situation like just suppose this is going to be the axis for the polar curves, and there are two angles given to you. One is going to be theta equals say alpha, one is going to be theta equals beta, and there are two curves. This is the curve r equals f1 theta, and this is going to be r equals f2 theta. You need to find the area in between. The formula is going to be 1 by 2 integration from alpha to beta r2 square minus r1 square. Okay, that means for the rest minus the closest to the origin square. And this is how you will be finding the area. So it is clear that the intersection is at pi by 6. And from pi by 6 to pi by 2, if you take a strip, this is going to be the elementary strip. So from pi by 6 to pi by 2, I can easily get the area using the formula I told you. It is going to be 1 by 2 integration from pi by 6 to pi by 2. For the rest is the curve C. The curve C is going to be 2 sine square theta minus nearest is the semicircle 1 by 2 square d theta. This is the reason you will be getting this is represented by this curve. Yes. So this is the area you will be getting from pi by 6 to pi by 2. And see, I made it twice so that I will be able to cover all the area. This part is done, but one part is left. Which part? This part area is left. I need to add this area because this is the reason bounded by the angle theta equals how much? Theta equals 0 to pi by 6. Sorry, it is theta equals 0 to pi by 6. So I will be adding the area from 0 to pi by 6. I forget to mention 1 by 2 there. This is going to be 2 sine square theta d theta. And now because calculator is available to you, you can make use of calculator. You will be able to get the area. Can you please use your calculator? Try to help me with the answer, or you can use Desmos there. Wanna use anyone?
Yeah, we can use Desmos.
Let me just use the Desmos. So let us use Desmos there. I'm going to hide all this. What I need integration part. So if I multiply by 2, these 1 by 2, 1 by 2 will be cancelled out. So I should be getting only the integration part. So integration from pi by 6 to pi by 2. This is going to be how much? I forget to mention square there. It is whole square. Okay, R2 square. There's a mistake. This is going to be 2 sine square theta whole square minus you are having 1 by 2 whole square, and then after d theta. Any doubt there? Yeah, this is d theta. There seems to be some issue. Let me just check what is the issue there. Yes, this is the value you will be getting for the first integral. The second integral is going to be, let me just copy it and again pasting. This time you only have one single curve, but the integration is from 0 to pi by 6. The answer is coming out like 0.2. Let us just add them. 2.06676. Let me just use 7 there. Okay, now rounding of the number 2245 and 0.0276256, something like that. The answer coming out will be like this one. So all the calculations are done using Desmos. I hope you will be in a condition to understand what I did here. Any doubt?
Wait, why did you add them?
Because the addition sign was there. See, you need to find the area. So there are two areas. First area is going to be this one, maybe pink one. Second one is this area. You got this area separately using this first
Okay,
integral.
yeah.
And then after the second integral is representing this part of area. And then after you will be, you are able to get the whole area. Any doubt?
No. Do you
Perfectly
know
okay.
multiply by 2?
Multiplied by 2. Yes, this when you multiply by 2, 1 by 2, 1 by 2 will be cancelled out. So you will be left with the integration only. So I calculated the integration only and added these two values.
Okay.
Okay, so I cancel out these two there. Any doubt? I used symmetry here.
Okay.
So let us go to the next question, that is the C part. In C part, again, we are going to make use of the Desmos. See, calculator is allowed for you, so you should be able to make use of calculator. So they have given you what is dx over d theta for the curve C. And for theta from 0 to pi by 2, find the value of theta that corresponds to point on the curve C that is furthest from the y-axis. Whatever the y-axis, you need to find the furthest point. X is what is the furthest point? That means the maximum value of x is required. We need to find the maximum value of x basically. Y-axis, you need to find the furthest point stands for the maximum x value. If you wish to read the question once more, let me just tell you using the graph. What is the meaning? So the question is like, you just start roaming around the y-axis along the curve C there. And just suppose you are at this point, then there will be x coordinate, y coordinate. You try to find the distance from the y-axis. Any doubt? So you need to find the point where x is you are furthest from the y-axis. So maximum x value is required there. That means I'm going to find the maximum minima in the interval 0 to pi by 2. And for that, I will be finding the critical values by putting it equals to 0. And how can I do this? Again, let us just use Desmos. I will change the orientation. Yes. Let me just erase everything here. Now, you please try to help me. If I consider the function y to be 4 sine t cos square t, not t should be here. Have we made any mistake in writing? Yes, now the graph is clear to you. From the interval
Mhm.
0 to pi by 2, from the interval 0 to pi by 2, you need to just check the graph. One point is 0. This point is going to be how much? Pi is 3.14. Pi by 2 is going to be how much? 1.5, something like that. So there are three values you can see. So out of these three values, I will be choosing only two values. So the values of theta, the independent variable, I can tell you the value of theta I'm getting here is going to be either 0 or 0.95532. So again, I will be using the candidate test. It stands for there is a function x given to for the value of theta, I will be trying to get the value of x there. What is x? X is going to be r cos theta. Am I right? This is your
Yeah.
x for you. And I will be testing the value of x for different values of theta in the interval. The first value is going to be 0. The last value is going to be pi by 2. And the middle value is going to be theta equals 0.95532. X equals r cos theta is going to be how much? What was r? R was 2 sine square theta cos theta. This is the value I will be testing. Any doubt for these three values? So whatever the maximum you get, that is going to be the maximum for you. Let us just try to get the value. So I will be defining a function like ft we defined earlier. It is 2 sine square t uh, multiplied by how much? What was the second function? Cos t. Okay, and is there any issue? Yes, there is a issue in the writing style, I hope. And this is the function. I need the value at 0. I need the value at 0.955. What was the value? 95532. And I need the value at pi by 2 there. Okay, so these are the values you have obtained. So the maximum value you have obtained is at 0.9532. Any doubt? The
Yeah.
maximum value you have obtained is going to be 0.9532. So this is how you will be able to find the value of theta. The value of theta is 0.95532, for which the point is going to be furthest from the y-axis. Any doubt there?
No.
Perfectly okay. So let us go to the D part. D part says that a particle travels along C so that d theta over dt is 15. Find the rate at which the particle distance from the origin changes. Particle distance from the origin is represented by r there. And what was r? R, as per the question, it is 2 sine square theta. So what you need rate of change with respect to the time. It is going to be 2 sine theta cos theta multiplied by d theta over dt. Do you agree?
Yeah.
Using the chain rule. D theta over dt is already given to you. What is the value? It is 15 for you. It is 15. So, and I can rewrite this as sine 2 theta. So this is 15 multiplied by 2, going to be 30. I can write 30 sine 2 theta. You need the value dr over dt at theta equals 1.3. Plug the value and calculate. Let us just calculate the value. 30 sine 2.6. Let us calculate 30 multiplied by 2.6. What is the value? 15.4654. If not an issue, This is the rate of change we are getting. Any doubt? So this is using the calculator. Now we are having questions without calculator help. You need to try these questions. Let me just start with question number 3, part A for you. A student start reading a book. Let's read the question. At time t equals to 0 minutes and continues reading for the next 10 minutes. So 0 to 8, 10. The rate at which the student read is modeled by the differential function r. The rate is going to be modeled by the differential function r, where RT is measured in words per minute. So 0 time 90 words per minute when he started. At 2, it is 100 words per minute. At 8 minute, 150 words per minute. At 10, it is 162 per minute. That means it is increasing continuously. The first question is you need to approximate R1, a derivative at R1, that is rate of change of reading per minute when time is going to 1 there. Using the interval, average rate of change, using the interval 0 to 2. So I hope 1 will be somewhere here. Am I right?
Yeah.
So if 1 is here, so I should be using the interval 0 to 2 to approximate R prime 1. R prime 1 is the rate of change. So approximation is required. I don't have the value at 1 there, but yes, I have the value of words at 2, value of words at 0, divide by 2 minus 0. This is the only thing I have got from the table. I will be using them to approximate the change. Divide by 2 there. How much it is? Is it going to be 5 words per minute?
Yeah.
I hope it is an easy task for you, not so big difficult task.
Yeah. That makes sense.
Next, let us look at the B part for you. And read the B part for you. Must there be a value C for the interval 0 to 10 such that RC equals 155? RC equals 155. Let us just try to check if this is the situation there. Can you please just look at the table? You are having R0 is 90. R10 is going to be 162. Am I any doubt? And is it given to you that RT is differentiable function? Check. RT is differentiable function. So why I'm joining differentiability here? Because there is a condition, there is a statement. Every differentiable function is continuous. Every differential function is continuous there. So that means to say that our RT is continuous. The CTS stands for continuous on the interval 0 to say 10. Any doubt? You have R0, you have R10. R0 was 0, you have R10 was 162. Because it is continuous, so certainly there will be some time where you will be having 155. Do you agree? What we
Yeah.
have used, this is the theorem. This is a theorem actually. It is called the intermediate value theorem we have used.
Intermediate. Yeah, I know that. Yeah.
Okay. And intermediate value theorem used for the continuous function. I told you why it is continuous. Did you get the idea? Because it is given to you that R is differentiable. Every differential function is continuous over the interval given to us. So I find out that from 0 to 10, it is continuous. So using continuity, you get the applying the intermediate value theorem, you got the answer. Is it difficult?
No.
I hope no. Perfectly okay. Now, for the next question, you may need the table. So some calculation may be required. And the next question. Just look at the question, please. How we are going to solve, I'll tell you. use the trapezoid sum with the three subintervals indicated by the data in the table. Approximate the integral 0 to 10 there. Okay. How should you do this? Using trapezoid rule. So using trapezoid rule is basically 0 to 10 RT. It is going to be equals to from 0 to 2 RT. You can just try to find out. From 2 to 8, this is the second interval given to you, RT. And from 8 to 10, this is the third interval I will be approximating using trapezoid rule. Whenever you apply the trapezoid rule, the formula is, see, if it is A to B, ft dt, the trapezoid rule says that, first of all, try the difference, like difference of the interval B minus A, divide by 2, and get the value of the function at both the endpoints. This rule is called the trapezoid rule. So you, for each interval, you are going to apply the same. So the difference is going to be 2 minus 0 divided by 2. Tell me the value of R0 plus R2. R0 and R2 are given to you. Similarly, you have 8 minus 2 by 2. You need to apply the value R8 minus R2. And for the last one, it is 10 minus 8 divided by 2. This is going to be R at 10 minus R at 8. Any doubt?
No.
Okay, so let me just post this here. So after applying the value, just simplifying calculate 2 by 2, it is going to be 1. R0, oh, sorry, the sign is going to be positive. My mistake, the sign is going to be positive. It is going to be 1. R0 is 90 plus R2 is 100. 90 plus 100, whatever it is. 8 minus 2 is going to be 6 by 2, that is 3. R8 is 100, 150, sorry. R2 is 100, right? 10 minus 8 is 2 by 2, that is 1. R10 is 162. It is R10 basically. R8 is 150. Agree? Simplify all this, get the answer. Let us use Desmos again to calculate all these values. Give me a second, please. Let me erase unnecessary things. So it is 90 plus 110 plus 3 times 150 plus 100 plus 162 plus 150. I made a mistake there. Yes, it is 1262. Have I made any mistake in any calculation anywhere?
No. I don't think so.
150 plus 162. So yes, I hope so. There is no calculation mistake. So if no calculation mistake is there, this is going to be the final answer for you. Okay, and because trapezoidal rule is an approximation, I will not be using equal to sign. Approximation sign will be used there. Trapezoid rule is only just an approximation of the exact integral. I'm going to use that only. Any doubt?
No doubt. No doubt.
Perfectly okay. Perfectly okay. So this part is done. I hope not an issue. Next is going to be the D part. This is going to be the last question. Then after we'll be having the rest of the question maybe tomorrow if there is a time possible with you. If you have a free time basically. This is question number 3, D part. Can you please read the question? Try to help me. A teacher also start reading at time t equals to 0 minutes and continue reading for the next 10 minutes. The rate at which the teacher read is modeled by, this is the teacher modeling, WT, is measured in words per minute. Based on the model, how many words has the teacher read by the end of the 10 minutes? How many words read? How many words read stands for? They're asking you to take the integral from 0 to 10 WT.
Hmm.
Carry it out. So it is negative 3 by 10. T square is going to be TQ by 3. Plus it is 8 T square by 2 plus 100 T. You need to just 0 to 10 apply this value. You will be able to get the answer. Okay. Let me use Desmos again because we can use right now Desmos. Yes, the value is going to be integral from 0 to 10 and bracket is started negative 3 by 10 T square 80 plus 100 bracket close dt. The value coming out is 1300, right? So this is the value we are getting. Is it difficult? Is it
No.
difficult? Perfectly okay. So there are two questions left, 4 and 5. We will be doing this question maybe tomorrow. I hope today's lecture
Okay.
will be clear to you. Any doubt here?
It's all clear, yeah.